Hey Algebra, today we're doing lesson 5, summarizing deviations from the mean. And if you remember in lesson 4, we talked about deviations from the mean. So we would calculate the mean using our calculators or by hand, and then we would take our value. So after we did that, we would take the value from the dot plot or whatever, we would subtract the mean, and that was called a deviation from the mean. A little review there. So today we are going to calculate the standard deviation. So there's quite a few steps here that we're going to go through piece by piece. So you may want to get a highlighter out or some way to just mark the important parts in your classwork or in your notes. All right, what you see here is a dot plot of the lives of the brand A batteries from lesson 4. Seems to me that the dots are missing, so let me add those really quick. That looks good. We have a dot down here. That's gray, I don't know why. About 83, below 95 at 94, and 96, and then 106, 113, and 114. Okay, there is our dot plot. How do you measure the variability of this data set? One way is by calculating the standard deviation. So first, find the deviation from the mean. If you remember back from lesson 4, our mean for this value was, I'm looking back in lesson 4, 101. So what we did here is we took 83 minus 101 and got negative 18. 94 minus 101 is negative 7. 96 minus 101 is negative 5. 106 minus 101 is 5. 113 minus 101 is 12. And 114 minus 101 is 13. So that right there is the first step. Find each deviation from the mean. Then you need to square the deviation from the mean. So you're taking negative 18 and squaring it. Okay, negative 7 squared. These should all be positive numbers, because when you take a negative and square it, it's negative 7 times negative 7, which gives you 49. Negative 5 squared, etc. So that's step 2 is square the deviations from the mean. For example, yes, we got it. So that's what we just did. Cool. Step 3 is add up the squared deviations. So you're going to take all these numbers and add them up, and you get 736. This result is the sum of the squared deviations. Okay, that's what we've done. The sum of the squared deviations. The number of values in the data set is denoted by n. So for this sample, we have 6 points on our dot plot. The values in the data set, I've got 6 of them. So I need to divide the sum of the squared deviations by n minus 1, which is 5. So from the previous slide, I have 736 divided by 5. So my answer there is 147.2. Last step, if you take the square root of 147.2, and which to the nearest hundredth is 12.13. So in your calculator, you're doing that. 147.2, which you get 12.13. That right there is your standard deviation. You did it. It seems like a very complicated process at first, but you will soon get used to it. We conclude that a typical deviation of a brand A battery lifetime from the mean battery lifetime for brand A is 12.13 hours. The unit of standard deviation is always the same as the unit of the original data set. So we had hours, we're doing hours. So the standard deviation to the nearest hundredth with the unit as 12.13 hours. How close is the answer to the typical deviation that you estimated at the beginning of the lesson? Now, if you remember back to the beginning of that lesson, we sort of guessed a deviation of a typical deviation. You may have to look at your lesson 4 notes. A typical deviation of about 10 hours. So we're pretty close. I'm okay with that. Alright, let's try this one on our own. Now you can calculate the standard deviation of the lifetimes for 8 brand B batteries. The mean was 100.5. We already had the deviations from the mean. We calculated them. Now we need to square them. Okay, so I'm getting my handy dandy calculator out. I've already squared them, so I'm going to write them in. 756.25. I'm out of room, so we're going to go back and forth. 600.25, 72.25, 42.25, 90.25, 272.25, 306.25. I've typed these all in my calculator earlier, so it's easy just to copy them down. Awesome. Write the squared deviations in the table. Check. And then that last question, add up the squared deviations. So I'm going to sum all of these, add them up in my calculator, and I have 2,692, which I'm going to need on the next page. Okay, what is the value of n for this data set? Here I have n equals 8, so I'm going to take the sum of deviations, divide by n minus 1, which is 7, and I get 384.571. Take the square root of that, and I get, so square root of 571, 19.61. How would you interpret the standard deviation from that you found in exercise 4? Remember to give your answer in context of this question. Interpret your answer to the nearest hundredth. So the standard deviation, 19.61, that's the typical deviation of a brand B battery lifetime from the mean battery lifetime for brand B. So 19.61 is a typical deviation of a brand B battery lifetime from the mean battery lifetime for brand B. Alright, moving on. Jenna has bought a new hybrid car. Each week for a period of 7 weeks, she has noted the fuel efficiency in miles per gallon of her car. And there's the results. Calculate the standard deviation of these results to the nearest hundredth. Be sure to show your work. So first of all, I have the mean, which I used my handy dandy calculator to find, is 44. Then I want the deviations from the mean. So I'm going to take 45 minus 41, 45 minus 44, 44 minus 44, 43 minus 44, 44 minus 44, 45, 44, and 43. I'm going to add all these up. those, cancel those. Oh, sorry. Deviations from the mean. I'm squaring them first because if I add them up, they all cancel out, which is crazy. So I need to square them first. 1, 1, 1. Now I'm going to add them up. And I get 4. Cool. My n is 1, 2, 3, 4, 5, 6, 7. So I'm going to take my added squares and divide by n minus 1. That gives me 2/3. And then I'm going to take the square root of 2/3, and I get 8.82 miles per gallon. Cool. What's the meaning of the standard deviation? We just found in exercise 6. So I have 0.82 miles per gallon. That is a typical deviation of a weekly, what are we doing? Fuel efficiency is what she was collecting data on. I forgot an I, sorry. Fuel efficiency value from the mean. Cool. Summarizing what we did, we learned how to calculate the standard deviation, which are 6 steps. Crazy. And then the unit of the standard deviation is always the same as the unit of the original data set. The larger the standard deviation, the greater the spread or variability of the data set. Awesome. Good work.